Hi, carrying on, question 21. We got a hemisphere and a cylinder stuck on top of each other, and it tells you that the ratio of the heights here to here gives us this information right here. It tells you that that ratio is 3:1. So that's it's going well, isn't it? That's 1, that's 3. If that's r, the radius of the hemisphere, then this is 3r. And altogether, the height of the whole thing will be 4r. Okay, because r is kind of important to us here. To work out the volume of this, we can do it in two parts. We can do the hemisphere, okay, which I'm going to call hemi. And to get that, we use, it's a half of, not a quarter, a half, because it's a hemisphere, times the volume of the sphere, which is 4/3 pi r cubed. And in this case, the radius is r, because that's what we have, our unknown volume there. We want to find r, that's what we're looking for. This gives me 2/3 pi r cubed. So for the cylinder, and I do know how to spell cylinder. For the cylinder, we have the volume is equal to pi r squared times h, but h in this case is 3r. So altogether, that gives me 3 pi r cubed. We can add those together, and that gives us 3 2/3 pi r cubed. 3 2/3 pi r cubed, and according to the question, we can see that that's 792 pi. We can cancel the pi's. Oops, it's going well. Okay, we can cancel the pi's. So 3 2/3 r cubed equals 792. Let me grab my calculator and do 792 divided by 3 2/3. 792 divided by, use the right function on the calculator to type in 3 2/3, or in your head, turn it into a top-heavy fraction. Okay, so r cubed, as a top-heavy fraction, 3 2/3 is 11/3. 3 times 3 is 9, plus the 2 is 11. So r cubed equals, from using this, I get 216, which means that r equals 6. Great, well done. We have not yet finished answering the question, because the question says work out the height of the solid. So, going back to the correct question, the height is 4r. So the height is 24. 6 times 4. So there's our 6, and there's our 4. So 6 times 4, the height is 24. Okay.